students, good morning. And in this class we study about selection of transformer substation. Yesterday class we have seen about the problems. I think the problem is young, so now we study about the selection of transformer substation. So while selecting the transformer substation, we need to consider economy of operation. So while operating a transformer, we should see that it is economical, and technical suitability, whether the transformer is required in a particular place or we can replace it by connecting a feeder. Also we can, so if it is required, then only we need to connect a transformer. Technical suitability, then cost, long-term gains. So what will be the long-term gains after installing the transformer, that also we need to see. And transportation constraints, whether the transformer is easily transportable, so whether the center is near to the roadside, it is easily accessible, etc., that also we need to see. And handling facilities, so we need to see that the sufficient transformer is in bulk in size, so some transformers, so it should be easily handled. So corresponding equipments like JCBs, etc., should be arranged easily and should be handled safely without any damage. And availability of supporting switchgear. So what are the supporting switchgear for a transformer? That is lightning arrestor, air brake switch or vacuum circuit breaker, CTPTs. Okay, so these are all the switch gears are available nearby the transformer. So it should be there in the primary side of the transformer. So why? Because the primary side is of high voltage and secondary side is of low voltage, and we need to see that the production must be ensured morely on primary side rather than secondary side. So primary side, it is of high voltage, so more importance is given to the production on the primary side. Okay, so these are all the conditions while selecting a transformer. So we see the factors which decide the selection of transformers. Say while in an industry we need to select a factory, in a factory we have 270 kVA of supply, order requirement is there, so we need to select a transformer. So what are the different factors which affect the selection of a transformers? So first is the maximum demand. We need to calculate the maximum demand of the particular factory, and based upon that one we need to select. And future expansion, if any future expansion of the factory is there, whether we are opening 1 or 2 units, etc., in the upcoming years. And spare capacity means, so we need to ensure that the transformer should not be operated in the full load, it should be operated in the 50% only, so that the spare capacity should be there. See, the spare capacity should be there. While in a long term run, if an industry is hoped to expand its units, then we cannot install the transformer suddenly at a sudden, so that some spare capacity should be allocated in a factory, so that. And next one is statutory requirements and site conditions. So these are all the conditions, factors which decide the selection of transformer. Okay, next, site condition means the site should not be dry, the site should not be wet, it should be a dry site. And we need to say that whether it is of urban or rural. So in an city, metro city and all, we can have the indoor type of substations. In the urban area we can have the outdoor type of substations. And okay, so these are all the factors which decide the selection of transformers. Now what are the standard rating of distribution transformers? The standard rating of distribution transformer is 11 bar 433 kV. So it is of the pole mounted transformer. So the kilovolt ampere, so transformer specification is done in kVA. So the normal kVA, the lowest kVA which we can expect is 50 kVA, and the highest is about 2000 kVA maximum. So it will range in 50, 63, 80, 100, 160, 200, 250, 350, 315, 400, 500, etc. So the cooling will be oil natural or air natural cooling, ONAN cooling, or oil natural or air forced. So see here, in this type of transformer we are putting a fan here. So that is oil natural air forced type of cooling. So like this also we can employ the cooling system. Oil natural, air natural is normally in the outdoor substation, and once the transformer rating increases, we need to see that the sufficient fans should be installed in the radiators so that the air will be forced and it can cool effectively. And here also you can see it is of outdoor substation. There we are not installing any fans and all, so it is oil natural and air natural. Okay, the parallel operation of transformer. A pair of transformer is said to be a parallel if they are connected in parallel on at least two sides for meeting higher loads. So the transformer can be operated in parallel to meet the higher loads. So condition for parallel operation: the same vector group, its turns ratio should be similar, it should same have percentage impedance, and ratio of rated capacity of a transformer shall not be more than 3:1. The ratio of rated capacity of the transformer. So if you are having two transformers in connecting, so the rated capacity of the one transformer should not be 3 times greater than the other transformer. So it should not be more than 3:1. So if you are connecting a transformer, first transformer has 100 kVA and other transformer has 400 kVA, then it comes in the 1:4. So this should not be taken. So you should have to see that the one transformer is 100 kVA and other transformer is less than 300 kVA. So that, like that only we can able to connect the two transformers in parallel, and it should have same vector group, turns ratio, and primary turns ratio is the ratio between number of turns in the primary to the number of secondary and primary turns, that ratio, and say it should have same percentage impedance and all. So next one we see selection of substation design. Say in a substation design, consider that you would like to choose a transformer to supply power to a factory which requires a maximum of 270 kVA of power at 400 volt on LV side, and no expansion is considered near for future. For future expansion they are not considering, and we need to see that 270 kVA of power at 400 voltage on LV side. The power will be provided by connecting the factory to 33 kV MV voltage levels. Choose the transformers. So transformer to supply the power to a factory which requires 270 kVA at 400 volt. So this is the maximum load of that. This is the maximum, requires a maximum of 270 kVA, and the secondary voltage is 400 volt, that is LV side is secondary side, and no expansion is also considered. The power will be provided by connecting the factory to 33 kVA MV voltage, that is so this will be your primary voltage. So the 33 kV is the primary and 400 kV is the secondary. Okay, 33 bar 400 kV. So it comes here 33 bar 400 kV. Okay, സോ അതായത് ഏത് ഹയർ വോൾട്ടേജ് നമുക്ക് നോക്കാൻ വേണ്ടി ട്രാൻസ്ഫോമർ എപ്പോഴും നമ്മളിവിടെ ഉപയോഗിക്കുന്നത് സ്റ്റെപ്പ് ഡൗൺ ട്രാൻസ്ഫോമറാണ്. അപ്പോൾ സ്റ്റെപ്പ് ഡൗൺ ട്രാൻസ്ഫോമർ ആകുമ്പം ഇത് ഹയർ വോൾട്ടേജ് നമ്മൾ എന്തിനെടുക്കണം, പ്രൈമറി എടുക്കണം, ലോവർ വോൾട്ടേജ് സെക്കൻഡറി എടുക്കണം. സോ 33 bar 400 volt. Okay, next we need to see choose the transformer. So the powers, that is in terms of kVA, so you see it is of 270 kVA. It is of 270 kVA. So whatever we can have, we can start it from 350 kVA, 100 kVA, 250 kVA. അതിനുശേഷം വരുന്നത് ഒന്നുകൂടെ ഉണ്ട്, 315 kVA is also there. 315 kVA, but you cannot choose 315 kVA here. Why? Because you need to see that if any short circuit and all, if anything comes here, so the transformer should be able to withstand that one. അതായത് ഈ എന്തെങ്കിലും ചെറിയൊരു എക്സ്പാൻഷൻ, ഫോർ എക്സാമ്പിൾ ഒരു ഓവർ ടൈമിലായി നമ്മൾ വർക്ക് ചെയ്തു, മാക്സിമം ഡിമാൻഡിനെക്കാട്ടിയും കൂടുതൽ വർക്ക് ചെയ്തു, അങ്ങനെ എന്തെങ്കിലും വരുമ്പം എന്ത് വന്നാലും കുറച്ച് ലോഡ് ട്രാൻസ്ഫോമറിൽ വരും. സോ ആ സമയത്ത് എന്താവും, നിങ്ങൾക്ക് ട്രാൻസ്ഫോമർ ബേൺ ആവാൻ പാടില്ല. ഓവർലോഡ് ചെയ്തിട്ട് ട്രാൻസ്ഫോമർ ഷുഡ് നോട്ട് ഗെറ്റ് ബേൺ. സോ ദാറ്റ് യു ഷുഡ് ഹാവ് ടു സീ. സോ ദിസ് വൺ വി കോൾഡ് ആസ് എ സ്പെയർ കപ്പാസിറ്റി. സ്പെയർ കപ്പാസിറ്റി പറഞ്ഞില്ലേ നേരത്തെ പറഞ്ഞത്, അതായത് ട്രാൻസ്ഫോമർ സ്പെയർ കപ്പാസിറ്റി പറഞ്ഞാൽ ഒരു ട്രാൻസ്ഫോമർ സ്പെയർ ഇടണമെന്നല്ല. ഒരു ട്രാൻസ്ഫോമറിന് വെറുതെ ഒരു ട്രാൻസ്ഫോമർ അവിടെ വെക്കണം എന്നല്ല. സ്പെയർ കപ്പാസിറ്റി മീൻസ്, ഫോർ എക്സാമ്പിൾ വി ആർ ഹാവിങ് എ ട്രാൻസ്ഫോമർ ഓഫ് 100 kVA. So we see the maximum demand is 100 kVA. Still we are opting, we can opt for 250 kVA or we can opt for 160 kVA. മാക്സിമം ഡിമാൻഡ് 100 ആണെങ്കിലും വി ക്യാൻ ഹാവ് 200 kVA ആണ് നമ്മൾ അവിടെ എന്ത് ചെയ്യുക. അതെന്ന് വെച്ചാൽ സ്പെയർ കപ്പാസിറ്റി എന്ന് വെച്ചാൽ സഡനായിട്ട് എന്തെങ്കിലും ഒരു സിനാരിയോ, പെട്ടെന്നൊരു ലോഡ്, ഫാക്ടറി ആകുമ്പോൾ എന്താ വേണ്ടി വരും, പെട്ടെന്നൊരു ഡിമാൻഡ് റൈസ് ചെയ്യും. അപ്പം ഡിമാൻഡ് റൈസ് ചെയ്യുമ്പം സബ്സ്റ്റേഷനൊന്ന് ഇൻഫോം ചെയ്യാണ്ട് ഫാക്ടറീസ് കൂടുതൽ ലോഡ് കൺസ്യൂം ചെയ്യും, കൂടുതൽ കറണ്ട് കൺസ്യൂം ചെയ്യും. അപ്പം അത് നമുക്ക് സപ്ലൈ ചെയ്യാൻ പറ്റണം. സോ അതുകൊണ്ടാണ് നമുക്ക് എന്താ ചെയ്യുക, 270 kVA we cannot take it as 315 kVA, we take next rating as 400 kVA. So that is why they are selected as 400 kVA. So in case if you are having it is having 570 kVA, it is having a 470 kVA, ഇത് എന്തൊരു 470 kVA ആണെങ്കിൽ we can select it as 630 kVA. Okay, and if it is having 570 kVA, then we can have 100 kVA, 800 kVA. And if it is having 770 kVA, we can directly go for 1000 kVA. Don't select nearby value, select the next near value. Don't select nearby value, select next near value, so next near value is 400 kVA. Okay, so next one we see about the primary voltage. The primary voltage we can have 33 kVA, 34.5 kV and all. So in the question it is directly given, so we can take 33 kV. And the secondary voltage, the question the direct is given, we can select 400 voltage. So the selected transformer size is 400 kV, 33 kV, 400 kVA bar, 33 kV 400 volt transformer. Okay, now you just see the typical layout of a single line diagram of a transformer. So in the transformer we can have the copper and load break switch. This we call as a gang operator switch. Then fuse star, delta bar star. So actually we are connecting the primary of the transformer to the delta. Why? Because we require only 3 lines, 3 RYB is being connected to the delta. And we can see 400 kV, 11 kV bar, 433 volt, 50 hertz 3-phase transformer. Okay, and next one we see the MCCB, rating of the MCCB. And you just see the rating of the gang operator switch 630 ampere. So these are all we need to study in detail in this class. So how can we design this single line diagram? So now we see the types of substations. So consider the distribution. This single line diagram will vary more depending upon the type of substation. That is the indoor substation, the single line diagram will be different compared to the outdoor substations. So that for that one, before going in detail about this layout, we just see what are the different types of transformers. So first one is the outdoor substation. Outdoor substation is the pole mounted outdoor substation and floor mounted outdoor substation. Next one is the indoor type floor mounted substation.